Hey gang, thanks for watching this particular bonus video before you head to the hubs and repeaters videos, because I got a little bonus information here for you, and it deals with the show interface command, particularly show interface E0. Because if you're new to my teaching style, what you'll notice is that I really like to do troubleshooting as we go along. I don't really like to do it or treat it as a separate entity, because very often when we're building things, and we build a lot of things from scratch in this course, everything from an STP network to frame relay to OSPF to everything in between, you're going to have some issues come up when you build those. So I don't really like to treat troubleshooting as, oh, we'll do this at the end. In Ethernet, though, it's a little harder to do that because it's a little harder to replicate all these things and show them to you clearly. So I want to introduce you to a couple terms here you may be familiar with, but I definitely want to tell you what they might indicate on your network. Because what we tend to do with the show interface command is pay attention to the top half of the output and not so much the bottom half, because we're so used to looking in the top half for the fundamental information we need. With Ethernet 0, we've got the hardware address, the MTU, the encapsulation, everything else. But we tend not to pay attention to the bottom half of it. And I want to pay some attention here to it because there's some important troubleshooting information here. Now, one line made this screen, so this is not the only line you're getting. But there we've got 5-minute input rate. And notice that there are two rates given to us, bits per second and packets per second. That's okay information. Then you've got your 5-minute output rate named the same way. But hidden in all this information down here, and mostly these are zeros on this particular lab router, and generally for these values that's a good thing. But I want to talk to you about a couple of these. And with packet input and bytes first, we have right near the top of the second half of the information. That refers to these values that are received in error-free packets. Now, that all sounds fine. It's like, hey, this is the good stuff. Well, the bad stuff's coming. No buffer. No buffer refers to the packets that were dropped, the number of them, because there was no room in the buffers to hold them. And that's not good. A term we're going to come back to again and again and again in the switching section, and it's a good idea to watch this one again after you go through the switching videos, broadcast storms. This is a situation where broadcasts slowly or not so slowly build up in your layer 2 network, and they build up to the point where your switch can't do its work. Well, it can't do its switching really, because it's just handling all these broadcast packets and the buffers are filled, and it's just frankly a real mess. Well, they don't happen immediately, and if you notice some slowdowns in your network to begin with, this is an excellent command to run. And you just run it a couple of times, a couple of minutes apart, a couple of hours apart, even if it's not a terrible network slowdown. And if you're watching certain of these values increment, you know there's a problem. Well, no buffer, there's definitely a problem, because broadcast storms can fill up the buffers, and literally these are packets getting dropped because there's no room at the end. We got literally no place to put them. Now, broadcast here, when it mentions receive 0 broadcast, that does include multicasts. Broadcasts are packets for everybody. Multicasts are packets destined for a group, but they are treated the same here. Now, these runts and giants. Runts are frames smaller than 64 bytes, and giants are frames larger than 1518 bytes. And that violates the IEEE 802.3 standards for the minimum and maximum frame size. Now, according to Cisco's website, and this is true, giants are often caused by a bad network interface card. I meant to say true because I've seen that as well. Now, bad NICs can cause runts, but again, Cisco's website and definitely my life experience will tell you that when you start seeing a lot of runts come in, that could be a big sign of a duplex mismatch. And duplex mismatches, they're not obvious. I'm not going to say they're really horrible to try to troubleshoot when you know where to look, because I don't think they are, but they're not obvious. They don't shut things down. They don't shut ports down. They don't shut routers down, anything like that. You still have data transmission. It's just not terribly efficient data transmission. So those are two values to watch if they begin to increment. Now, the input error, let me run this past you just to keep you sane people sane and you don't cross over to where I am. The input errors here, this is going to be the total of input errors, but it's not necessarily going to be the total of the 4 values right after it. Cisco's website even mentions this as well, that the input errors are also going to be totaling errors that are not shown to us here. So don't drive yourself insane thinking, okay, I got 10 CRCs, 10 frame, 10 overrun, 10 ignored. Why don't I have 40 input errors? Why do I have 50? What's going on there? Cisco even mentions that in several places on their own site and their own documentation. So don't think that's going to pop up on your exam, but it might help you keep your sanity. So let's take a look. Collisions, of course, refers to the number of collisions. And what might those indicate, you think? On a network that is set up for full duplex, hint, hint, and all of a sudden we've got collisions, which we shouldn't be having, theoretically, hint, hint, that could be our duplex mismatch rearing its ugly head as well, because that means somebody is transmitting at half duplex, and that could lead to data collisions. So that's a big hint there as well. Now, ignored, we looked at this up here with the CRC frame overrun and ignored. CRC, that's a version of our frame check. That's our cyclic redundancy check, and of course that's the recipient of the frame checking the frame's integrity, and it's for error detection. We know that's a version of the frame check sequence in FCS. So we know what that one is. Now let's go back to that ignored and so forth. Ignored means it's the number of incoming packets that were dropped because the internal buffers are approaching maximum capacity. So that's an indicator of a problem. It hasn't gone totally fatal yet. We haven't gone to no buffer yet, but we're getting real close. And again, broadcast storms can definitely fill up your buffers and make it impossible for non-broadcast legitimate packets just to get dropped because there's no place to put them in the buffers. CRC, we mentioned that. Now, frame right after that. Frame is the number of packets that have a CRC error, but that also includes some other errors as well. So don't expect CRC and frame to match up exactly. Overrun, that refers to the receiving hardware actually being unable to give the data to a hardware buffer. Now that's pretty busy. And the problem is the incoming data is coming in too fast for the receiver to handle. It's not necessarily a broadcast storm, but it is, it's just like a river coming in too fast. At some point the dam can't hold it back any further. Well, an overrun is simply, hey, that data is just coming so fast that some of it's just getting thrown out. We can't handle it. The receiving hardware literally can't do the job. Throttled is kind of like that. I think I've got throttles here, but yep, it is throttles actually. That includes or indicates the number of times the receiver was actually disabled. Basically, at that point, the CPU and or the buffers are just throwing their hands up saying, what do you want from me? The data is just coming way too fast, and that's what causes your throttle. So just a couple of things there to get you started with some troubleshooting there in this particular output. Again, knowing which ones indicate you might be looking at a broadcast storm, which ones would help to indicate a duplex mismatch, I think is a very good idea. Again, if you suspect that duplex mismatch, check your CRC, your frame, and collision counters, because on a full duplex network, we really shouldn't be seeing any collisions unless there is a duplex mismatch involved somewhere. So that's going to wrap it up for this particular look at show interface, and believe me, in the videos ahead we're going to be looking at hundreds of times, but we will be concentrating actually on the output in the top half, and I want you to see what's going on with the bottom half of that output as well. I'll see you in the next section. Thanks for watching.